Hey guys! So today we are going to be starting what is called the unit circle. And so I'm hoping that everything we've talked about so far and everything that you've been kind of looking at, it will all come full circle. See what I did there? Today. So we're going to be talking about what is called the unit circle. And the reason it's called the unit circle is because the radius is 1, okay? And so for this particular circle, all the radius lengths are equal to 1. And this actually gives us a lot of really good things to look at, to think about, and to talk about. Okay. Remember that one of your lessons had something about radians. Radians, remember, is the angle opening where the radius is equal to the opening, right? Or the arc length around the circle. Now, just because this is labeled as a 1 doesn't mean that this opening right here is a 1, or that this opening to this one is a 1. And so we've got to talk about the different degree measures as well as the different radian measures that are there. Okay, the first thing that I want to touch base with you are what these coordinates are. So first of all, this coordinate on the X and Y axis is 1, 0, because again, the radius is equal to 1 on a unit circle, okay? This coordinate up here, this is the point 0, 1. This point over here is the point -1, 0. And then this point down here is the point 0, -1. Now, the really cool thing about everything that we've been doing and everything that we've been talking about is that you can now go find the coordinate points of all of these other angles, all of the angles, even the ones that are in between the ones that I've made bigger. You can actually find those coordinate points based on what the opening or what the angle is in each of these angles, okay? And so that's what we're going to be kind of doing right now to get us started. We're going to start out pretty basic. The first thing that I want to do is I want to figure out what these angles are, okay? And so that's the first question that we're going to ask today. What is each angle, and why do I have these special ones marked? So why is there only 3 in between each one of the, like in each quadrant, that we're in, okay? So what is that angle measure? And then the second question that we're going to be figuring out today is, okay, well, if we know what the angle measure is, what is the point? What is the coordinate point? Not what's the point of what we're doing, but what is the coordinate point that matches each one of these little dots that kind of go around our circle, okay? So let's go ahead and get started. The first thing that we're going to do is we're going to find out what these special angles are and why these specific dots are where they are, okay? So the first thing I want to do is I want to go between degrees and radians, okay? What are these openings? Why are these marked what they are? Okay, so first of all, this point right here, yes, we know that that coordinate point is 1, 0, but right now I'm not worried about that, okay? My focus is going to be on what are the degree measures and the radians of each one of these points, okay? So first of all, remember just a couple of, well, actually, I guess it was yesterday's lesson, we did angles that are in standard form. So this is 0 degrees, okay? So this angle right here, if I start at the origin and go this way, this is a 0 degree angle. When I move this angle all the way around and I do a full circle or a full 360, this is also 360 degrees, okay? And then what I have marked off are each one of these dots, and I'm only highlighting these very specific dots because these specific dots have split our circle into even intervals, and each one of these dots or these openings between represents a 30-degree mark. And so the first thing that I want to do is I want to say, okay, well, let's go count by 30. So if I'm at 0, I'm going to count up. So this is 30 degrees. If I go another 30 degrees, this is now 60 degrees. So the opening, and I just want to show you with a different color, but this opening is 30 degrees. The opening from 0 up to here is 60 degrees. This whole opening is 60 degrees, okay? If I go straight up, this opening is 90 degrees. And then I can keep counting by 30s and go around. So I'm at 30, 60, 90. Now I come to 120, 150, and I'm just counting again by 30. So 3, 6, 9, 12, 15. Next would come 18. So this is 180. The next one would be 210, 240. This one is going to be 270, 300, and then 360 degrees. Okay. And so we're just counting by 30s. Now on your Google Slides, one of your slides is actually asking you to do that. So I don't know if you can see this right here, but this slide is actually asking you to count by 30s. So go ahead and go do that, okay? The next part is where you're going to be converting these degrees into radians. And I want to spend just a second doing that with you, okay? So let's go take these points over here. So if you're going to convert from degrees into radians, okay, this was another lesson that we did. Remember, you're going to take the degree and you're going to multiply it by pi over 180. Okay, and so when I do that with 0 degrees, I end up with 0. So this is also 0 radians. Let's go do 360. So if I take 360 and multiply by pi over 180, I'm going to get 2 pi. So this is 0 degrees, it's 360 degrees, it's also 0 radians as well as 2 pi radians. Let's go figure out 90 degrees. And so with 90 degrees, I'm going to multiply by pi over 180. And as I reduce, I end up with pi over 2. So here's 0. When I go up to here, I'm at pi over 2. Okay, let's go do 180. So if I go 180 degrees, what is this radian? Some of you might remember from the other video that this radian gave us a pi, but let's actually go do it and do the conversion. So 180 times pi over 180, I'm going to cancel my 180s and I end up with, there it is, there's my pi. Okay, so this is, again, this is 0, 2 pi, up here, or I'm sorry, 0. This is pi over 2. Over here is pi. And then we got to figure out what's down here. And then we reach 2 pi. And so if I take 270 degrees and I multiply by pi over 180, and I do some reducing to figure out what this angle is, let me cancel out those zeros. So now I need to reduce 27 and 18, and I'm going to leave this in terms of pi because we like our radians to be in terms of pi. So let's see, I can divide by 3. I can divide by 9, so I'm going to get a 3. Divide 18 by 9, and I get a 2. So 270 is also 3 pi over 2. Now, I have a really cool, easy way to help you remember. If you take a look at all of these angles, a little bit wider. This is 0. This is pi over 2, pi, 3 pi over 2, and then 2 pi. So I've got a really cool way to kind of help you remember what these angles are, and that's what we're going to do next. So on your Google Slides, you're going to also be counting the way that I'm going to be counting with you. So I'm going to show it to you. So you're going to be counting by degrees, which I've already done and showed you. And then you're going to be counting by radians next. Okay. And so that's what's coming up next. If you take a look at your Google slide, the one that I gave you, that's what this is. Okay. So we're going to start, first of all, with our every 30 degrees. So when it went from 0 to 30 to 60 to 90, 120, 150, 180, and so on and so forth. And now we're going to go count by radians, okay? So let's go take a look. So I have a little smaller unit circle, and let's go count this one by radians, okay? Let's see if I can get this a little bit clearer for you to see. Okay, so here we are again in radians. This is 0. It's 0 degrees. It's also 0 radians. Okay, and if I go all the way around and I get over here, I'm at 1 pi. So I promise there's a method to the madness. I just need you to listen, and I need for you to kind of follow along and count with me at the same time. Okay, so we're going to be finding these radians right here. We're just going to do 30 degrees first. Okay, the ones in the middle we're going to do in a couple of minutes, but we're just going to do these 30 degrees, every 30 degrees first. Okay, so if I take a look just from 0 to pi, if I just look at half the circle, okay, I just look at half the circle and I start counting from 0 and I count up, I get 1, 2, 3, 4, 5, 6. So there are 6 divisions from 0 to pi. So if I start counting up, this is 1 pi over 6. The next one is going to be 2 pi over 6. The next one will be 3 pi over 6. Which, by the way, on our last unit circle, we got 3 pi over 6, and that reduces to pi over 2, okay? So let's do that again. So we're at 0, we get 1 pi over 6, 2 pi over 6, 3 pi over 6. The next one is going to be 4 pi over 6, 5 pi over 6, and then 6 pi over 6. And 6 divided by 6 is the same thing as 1 pi, okay? So let's go all the way around the circle. So I'm at 1, 2, 3, 4, 5, 6 pi over 6. The next one is going to be 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and then 12 pi over 6. And 12 divided by 6 becomes also known as 2 pi. Okay, so again, I promise you there is a method to the madness. At some point or another, I'm going to ask you, hey, where is 7 pi over 6 located, right? And you're going to have to tell me, oh, it's in quadrant number 3. And you need to be able to come up with that number, you know, bam, bam, really fast. Right? So bam, bam, thank you, ma'am. 7 pi over 6 is in quadrant number 3. If I said to you, where is 11 pi over 6? You need to be able to say, oh, right here, it's in quadrant number 4. Okay? And so when you go through your Google slide, you're going to be doing the same thing. So here we are counting in 30s, and then here we are counting in terms of pi. Okay? So the next slide on your Google slide is getting you to count in terms of 45 degrees. So those numbers are those points that are in between. So the points that are in between the 1 pi over 6 and the 2 pi over 6. So those are the 45 degree lines. Okay, so let's go count by 45 degrees. Okay, so here we are again at 0 degrees. We're also at 2 pi, but let's start with degrees first. And so we're talking about these points. So if I count up 45 degrees, and then I go up one more time, I'm at 90 degrees. Okay. If I go another 45 degrees, I'm going to end up here, which is at 135. If I go another 45, I'm at 180 degrees. Okay. Let's keep going. If I add another 45, I'm going to be at 225. Another 45, I'm going to be down here at 270 degrees. One more 45 degree angle, I'm at 315. And if I went one more time, if I added 45 to 315, I would end up with 360 degrees. Okay, now here's what that looks like in terms of radians. So let's talk radians. Okay, so here's my 0 radian again. Way over here at 180 degrees, I'm also at pi, right? I'm at 1 full pi. So again, we're looking at this point, my 90 degree mark, we're looking at this point. So if I look just from 0 to pi, I'm cutting this pi into 1, 2, 3 fourths. And so each one of these marks as we go is going to be a fourth of a pi. Okay, so 1/4 of a pi is what each one of those marks are. So we can count our way around. So as I go up, I'm going to get 1 pi over 4. The next one is going to be 2 pi over 4. Now, wait a second. We're going to come back to this in a minute, I promise. Let's keep going. So I get 1 pi, 2 pi. The next one is going to be 3 pi over 4. The next one is 4 pi over 4, which is the same thing as 1 pi. Okay, again, we're looking at the points that are in the middle. So we're looking at these. So we're going to go another 45 degrees, and I keep counting. I'm at 1, 2, 3, 4. Oh, this is going to be 5 pi over 4, 6 pi over 4, and then 7 pi over 4. And then not to, last but not least, this is going to be 8 pi over 4, which is the same thing as 2 pi. Now, one of the things that I want you to keep in mind is that you are going to have to be finding these angles relatively quickly. Okay, and I promise you it is 10,000 times easier if you're able to just count. So from 0 to go 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, and get all the way around. Okay, it's much, much faster than doing all of these conversions that we were doing before. So 180 times pi over 180. Or 270 times pi over 80. It's much easier to just be able to count to get to 3 pi over 2. Okay, when you do 90 degrees, it's much, much easier. Instead of doing the conversion, it's much easier to go ahead and count to get your way around. So if I said to you, hey, how many degrees is 3 pi over 4? You can absolutely go through the conversion. So 3 pi over 4. How many degrees is that, right? You can absolutely do 180 times or over 180 over pi and go reduce and do all of this mess. Or you can say, oh, 3 pi over 4. Well, if I'm counting by 45s, right, because it's a fourth, I know I get 1, 2, 3 45s. Right? 3 45s is going to give me that, whatever that angle is. I don't know. My brain just totally died. What is that angle? 135. Okay. And so, 135. So it just goes a little bit quicker, it goes a little bit faster when you can actually count, okay? The other thing that we're going to be doing, so as you are filling out your Google Slides, right, you're going to count by 30s, you're going to count by pi's over 6s, you're going to count by 45s, count by pi's over 4, and then you're going to kind of put it all together. And that's what this slide is for right here, where you put it all together. And I definitely want you to go through. So I know there's about half of you, if not, 90% of you that were just dying to change this to pi over 6. You really wanted to make it a pi over 3, and that's completely, totally fine. Not, however, while you're counting. So I really want you to work on just counting by those. So it would be this green slide, just counting by those. But when you go to put it all together on the yellow slide, then you can go ahead and do some reducing, okay? But the last thing that we're going to talk about, and I mentioned this at the very, very beginning. So the last thing that we're going to talk about is the fact that we need to figure out, what is the point, right? So what is the point? What is the point of doing all of this? What are these actual coordinate points? And we're definitely going to touch base on this in a lot more detail in the next lesson. But for now, let's go figure out what all of these points are. And this is what you're going to do on this last slide that you have, okay? All right, so I know the last little bit that a lot of you are asking right now is, okay, Ms. Hunsaker, but what's the point, right? And that is exactly what this last question is what is the point? And so this is what trig will do for us. It will give us the actual coordinate points that we're working on the unit circle, and it will tell us exactly what those numbers are. Okay, so what's the point? I'm about to tell you what the point is. Okay, so here we are. This is right here, just the first quadrant. So this is quadrant number 1. And the first thing that we're going to do is we're going to figure out what are the coordinate points for all of these. Okay, so this is 0 degrees. It's also 0 radians. It's also 360 degrees. And because, again, we're on a unit circle, okay, the unit circle means that the radius is 1, okay? And so this point right here is the coordinate point 1, 0, okay? This point all the way up here is the point 0, 1. Okay, now let's go see if we can figure out what this point right here is. Okay, now this angle measure from what we just did a second ago is 30 degrees. If I drop a perpendicular line from this point that is right here at 30 degrees, if I drop that perpendicular line straight down, I end up with a right triangle. And so I can use our right triangle trig to help us come up with what these coordinate points are, okay? And so this length right here is our y length. This length right here on the x-axis, that is our x-axis, right? That's the x length. And so this is our x and our y. But if I use right triangle trig to get me there so that I know exactly what these numbers are in relation to the fact that this hypotenuse is just a 1, then I can do that. So if you pull up your little table, the one that I told you needed to get copied in your notes, the number that is going to go first is going to be the cosine. So what is the cosine of 30 degrees? And if you take a look in your notes, so I'm actually going to make this a little bit darker for you so you can see it. But the cosine of 30 degrees, that's your x, right? Because again, x, here's x, cosine is adjacent over hypotenuse, right? And so the x over 1, okay, the cosine is adjacent over hypotenuse. And so we're looking at the x number over 1. So if you look at your chart, the cosine of 30 degrees is root 3 over 2. If we wanted to try to figure out what the y number is, or what this height is, what is this coordinate point, right? How tall is this? Then I'm going to be doing from my 30 degrees the sine. So I'm going to be doing the opposite over hypotenuse. So remember, the sine is opposite over hypotenuse, and the opposite length is going to be the y over 1. And if you take a look at your chart, what is the sine of 30 degrees? The sine of 30 degrees is going to be 1/2. Okay? If I go take a look up here at this angle, so up here at 60 degrees, let's keep going with my 30, 60, 90 triangles, okay? So I want this opening up here. So this is a 60-degree angle. I'm going to drop a perpendicular, draw a triangle to my x-axis, okay? This is going to be my x coordinate. This is going to be my y coordinate. And let's see if we can go figure out what x and y are, okay? And so looking at 60 degrees, if I do the adjacent over hypotenuse, which again is 1, okay, that's a cosine because that's adjacent over hypotenuse. So I'm looking at x over 1. What was the cosine at 60 degrees on your chart? So if you look at your chart, that should also be in your notes, remember, the cosine of 60 degrees should be 1/2. Okay, if you look at finding out what y is, we need from our 60-degree opening the opposite over hypotenuse. So I need the y over 1. Opposite over hypotenuse, that's going to be the sine. So what is the sine of 60 degrees? The sine of 60 degrees is root 3 over 2. Okay, so again, we got this 1/2 by doing the cosine of 60 degrees. Looking at your chart, the cosine of 60 degrees is 1/2. Looking at your chart, the sine of 60 degrees is root 3 over 2. Again, looking at your chart, the cosine of 30 degrees is root 3 over 2, and the sine of 30 degrees is 1/2. Okay, let's go take a look at this angle. And so if you've been paying attention and watching this video at all, even though it's a pretty long one, this is, I'm going to drop a perpendicular. This is a 45-degree angle. And so this triangle, I'm going to do, if you look at our pattern, cosine comes first. I'm going to do the cosine of 45 degrees, and I'm going to put the sine of 45 degrees. So if there is nothing that you take away from here, I hope that you take away, no matter what it is, that your x coordinate is always the cosine of the angle, and your y coordinate is always the sine of that angle. And that, ladies and gents, is how you're going to fill out this last slide that you do. Okay? All right. So again, you're going to go start on your slides. You're going to count by 30s, count by pi's over 6s. Please make sure that you read the box. You're going to have to enter in your own text box to get to actually leave these numbers in here. Okay. You're going to count by 45s. You're going to count by pi's over 4s. You're going to put it all together and do some reducing. And then last but not least, you're going to go through and you're going to tell me what the cosine and the sine are of each one of those angles. Okay. happy trig, and I look forward to seeing you guys all today at 1 o'clock.